In this example, we want to find the sum of vector u plus vector v. So algebraically, it's easy to find the sum of two vectors. If the vectors are in component form, you add their x components, you add their y components, and that's the component form of their sum. The sum of two vectors is called their resultant. So in this example, if we add the x coordinates, we're going to have 1 plus 3. And if we add the y coordinates, we're going to have 2 plus 1. So the vector sum of u plus v is the vector in component form that's 4, 3. Now I also want us to look at what this would mean geometrically. And so we're going to actually look at it two different ways. We're going to look at the first way. Imagine that vector u was in standard position. So it is the vector that starts at the origin and has the terminal point of the vector ends at 1, 2. So that's vector v. So imagine at the end of vector v, we're going to draw vector v. At the end of vector u, we're going to draw vector v. So that means that from the end, the terminal point of vector u, we're going to go right 1, 2, 3, and up 1. So this is vector v. This initial vector was vector u. And their sum will be the vector that closes the triangle. So if we're counting over in our spaces, and this would be much easier to do on graph paper, we've gone to the right 1, 2, 3, 4, and we've gone up 1, 2, 3. So it should indeed make common sense that vector u plus vector v geometrically really is equal to the vector 4, 3. So in this method, which we'll just call method 1 for the moment, we draw in our first vector, and at the terminal point of that first vector, we put the initial point of our second vector and draw it in, and then close up the triangle, and that is our resultant. The second method for how to add two vectors geometrically would be to draw both vectors with their initial points at the origin. So vector u, again, is 1, 2. And vector v is the vector 1, 2, 3, 1. And so from these two vectors, we're going to create a parallelogram. And if we were to extend out this parallelogram to get the other side right here, it would have to be parallel to vector u, which means it would have had to go right 1 and up 2. And this one, to get the side parallel to it, it would have had to have gone right 1, 2, 3, and up 1. And so we've made a parallelogram using our initial two sides and then recreating those on the other side to get a parallelogram. The resultant is the diagonal of the parallelogram. And if we did indeed count over from the origin, this is 1, 2, 3, 4, 1, 2, 3 units up. So our resultant, again, u plus v, is indeed in component form equal to 4, 3. So we've seen algebraically how to find the sum, which is quite easy. Add the x components, add the y components. And then geometrically, to show that we've really found the right thing, in method 1, we draw in our first vector. At the terminal point of the first vector, you draw in your second vector, close the triangle to get the resultant. Or we can use the parallelogram method where we form a parallelogram using the two vectors as the sides, and the diagonal is the resultant of the vector.